Alright guys, welcome to today's tutorial. And in today's tutorial we'll be looking at something very important. We're going to be looking at plane geometry. So now, and under plane geometry we're going to be looking at coordinates. So coordinates simply means a representation of the position of a point along a line. So now said the representation of the position of a point. So now how you represent the position of a point along a line. For example, let's say you wanted to know the condition or the place where exactly something or a point is along a line. The next one we're going to is an axis. An axis is a directed line. So any line that is directed, whether upward or downward, then that line is what is an axis. So, and we have two types of axis. We have the x axis, is y axis. So you can see the one going the vertical line, that is your y axis, and the horizontal line, that is your what? That is your x axis. So this is very, very important. Please don't forget. So that is that. And also your x axis is also called abscissa. But then your y line, your y axis is also called the ordinate. So please don't forget. So maybe while we are in the course, I can, instead of using y axis, I can say ordinate. Instead of using the x axis, I can also use ordinate. So please don't forget. So then, and you notice that in a coordinate, we have something called the cartesian coordinate. So cartesian coordinate consists of being the x, we have the x axis and the y axis, but it's actually divided into four parts. So it's divided into four quadrants. So now this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is what? The fourth quadrant. So you notice the way I labeled it. You notice that this is anti-clockwise. So basically for this topic, or for this topic, okay, so the first, this is the first, the second, the third, and the, for example, let's say P. Let's say I want to locate a point P on this axis. Okay, now let's say point P is equal to x, y. Now please always note that in order for you to represent a point on an axis, right, so it's always comes by, the arrangement is always with x before y. For example, if I say P into 2, 3, now what I'm trying to say is that point P is what is having the position of P is 2, 3. What I'm trying to say is that this 2 is your x axis. That is, you are going to locate, on your x axis, you are going to look for 2 and put, okay, then your y is going to be what? You're going to look for 3 on your y. Then once you do that, then you trace it, then where the 2 meet, that is your point P. Okay, so that is it. Let's look at this one. How to plot a point on a Cartesian coordinate. So let's say we want to locate all of these points on a Cartesian coordinate. So how do we do it? So the first thing we do is that we are going to draw our axis. Let me call this my x axis. Alright, so I want to use this point to just bring out some stuff. So we are going to locate all of these points A, B, C, D. We are going to locate it on this coordinate. So what we are going to do is you can just label. We are going to label all of this. So let's label. So I can say this is 1, this is 2, this is 3, this is 4, this is 5, and I can call this one 6. Okay, so the next thing to do is I can also say this is minus 1, this is minus 2, minus 3, minus 4, and also minus 5. Okay, so now I can also say for my x-axis I can say that this is 1, this is 2, and this is 3. Okay, then for the negative y-axis, then I can say this is minus 1, minus 2, minus 3, and minus 4. Okay, so now let's locate point A, B, C, D on this coordinate. Now the first point is says that 5, 2. Now if the first point says 5, 2, so which means that if the point is 5, 2, which means that your x is 5, right, and your y is what, is 2. So now here, so we are going to do that on the x-axis. This is your x-axis, so let me label it x-axis, and this is y-axis. So on your x-axis you are going to locate you are going to locate 5, so this is 5 here. Okay, so you locate 5, then on the y-axis you are going to locate 2, so this is your 2 here. So now you are going to trace this, you trace it like this. Okay, you trace it till it's going to meet, you know your 5 is here, you can trace it up like this. So you notice that they're actually meeting at this point. So this is your what? This is your point A. So this place that I start is your what? Your point A. So you call it 5, 2. That's your point A. Then the next point is that said B, point B is minus 2, 3. So which means that your x is minus 2 and your y is what? Is 3, isn't it? So now let's go. So on the x-axis I'm going to locate my minus. So this is x-axis and this is minus 2 on the x-axis, so that's this point here, and my y is 3, so y is 3, so this is y here is 3 here. So what I'm going to do is just I'm going to trace it, so until it meets this one. I'll trace this one up again so that they'll be able to meet. So you notice that they are meeting here, right? So this point now is my B, so my B is what is minus 2, 3. So here is my B, here is my A. So the next thing to do is let's go to locate point C. Point C say that minus 5, minus 2. So now minus 5, so my x is equals to minus 5 and my y is equals to minus 2. So x, this x-axis, right? So the horizontal line is the x-axis while the vertical line is the y-axis. So I'm going to locate minus 5 on the horizontal axis. So this is minus 5. Okay, locate it, and on the y-axis I'm going to locate minus 2. So this is minus 2 here. So I'll trace it to where it's going to meet with minus 5. So they are meeting here. So this is my point C. That is minus 5, minus 2. Then finally, then for the last one, it says that D is equal D into 5, minus 4. So my x here is 5 and my y is equal to minus 4. So I'm going to locate x. X is minus 5 here. You can see x is minus 5 here and y is minus 4. So here is minus 4 on the y-axis. So I'm going to trace it to where it's going to meet this point. Okay, so here is my what? Here is my D into what? Into 5, 4. So that is how to locate or how to plot a point on a rectangular Cartesian coordinate. The next one we are going to look into is what we call the distance formula. Okay, so for example, let's say now this is, you know, the other one we did, we locate 2 points, like if you are given 2 points. Okay, so now for this one, where this is a distance now, you know, a distance comprised of 2 points, right? 2 points joining together. So when you join 2 points together, then it becomes a distance. Please note that when you join 2 points together, let's say you have a point A and B, once you join 2 points together, it becomes a distance. So now how do we find how do we how do we what is the formula we can use to calculate for the distance between 2 points? So for example, let's say our first point here is P. So let me call this first point here P, and it's comprised of what? Of x1 comma y1, and this point here, this other one, let me call it Q, comprised of what? S2 comma y2. So now what we are trying to say is that if this point is Q, right, and it's x2 comma y, so which means that on the y-axis, so let's trace something like this. So on the y-axis here is now is your y2, because you have to locate it. If you have to get the point Q here, for you to get the point here has to be y2. Then if you trace it down, let's say you trace it down, let me trace it down like this. Here is going to be what? Your x2. Now for this P, now here also you trace this one to this side, here will be your x1, and when you trace it like this, then here will be your what? Your y1. Okay, so now what we want to look for is you want to get the what? You want to get the distance of, want to get distance between P and Q. That's the blue line, the inclined B line. So how do we do it? So first of all, when you look at this looks like a triangle, right? So here we are going to use Pythagoras theorem. Pythagoras theorem says that hypotenuse square is equal to opposite square plus adjacent square, isn't it? So now please know that the longest side of a right angle triangle is always the hypotenuse, right? So then the other side you can just predict, you can get yourself the opposite and the adjacent, but the longest side is what? Is the hypotenuse. That is what really matters most. So now for you to get the longest side, now let me call this point O. Okay, so now the hypotenuse, that's this side here, is the hypotenuse, so you can call it PQ. So PQ square is equal to, let me call this one opposite, that's OQ. Let me call it OQ square. Okay, then plus the adjacent, then call it OP square. So now PQ square is what we are looking for, because that's the distance between the 2 points. The 2 points you are looking for is points P and Q. So PQ square is equal to OQ. Now OQ is the distance between this point and this point. Now this point is what, when you look at it to this side, is your y2, right? And point O is what? Is y1. So you can call it like y2 minus what? Minus y1 put square. Okay, then plus, now OP, that is distance between this point and this point, right? So this point is what? Is x2, and this point is what? Is x1, isn't it? So for you to get distance between this point and this point, so you are simply going to subtract this one from this one to get distance from here to here. So it's going to be what? x2 minus x1 square. So which means that square is equal to what? Y square plus minus y1 square, then plus x square minus x1 square. So what am I going to do? I'm going to take the square root of both sides. So therefore my distance of PQ, that is the distance between PQ, sorry, there's no square here, is going to be the square root of, that is y square minus what? Minus y1 square, then plus x2 minus x1 square. We have to find the distance of point PQ is 5,3, and Q is minus 2,4, and you have to find the distance between these 2 points. So for you to get distance between these 2 points, so your PQ is going to be, don't forget our formula, that is square root of what? Of x square 2 minus y2 square, then plus y2 minus y1 square. So which is going to give us the square root of, what is your x1, this will be your y1, Here is your x2, will be your y2. So you can leave it like that, will really help you. So now my x2 is what is minus 2, then minus. What's my x1? My x1 is 5, so I put it in square, then plus, open under bracket. Then what's my y2? My y2 is 4, and what's my y1? My y1 is what? It's 3 square. So which is going to be what? So which is going to be square root of minus 2 minus 5 will give you minus 7. Okay, then plus 4 minus 3 will give you 1. So we also square it. So what's the square of 7? Square of 7 is 49. Then plus what square of 1? Square of 1 is 1. So it's going to give you a square root of what? Of 50. So therefore the distance between PQ is what? Is square root of what? Of 50. So you can use your calculator to convert it. For example, let's say we are given m. Let's say we have a point M which is minus 2, 3, and another point N which is 6 and 0. So it's a point 2. So now we have to find the distance between M and N. So we just say the distance between M and N is equal to square root of x2 minus x1 square, then plus y2 minus y1 square. So which is going to give us the distance between M and N is going to be square root of, what's your x? So let's label it. So here will be our x1, y1, x2, y2. So now what's my x2? My x2 is what? Is 6 minus. My x1 is what? Is minus 2. So don't forget, so you have to put this one in bracket because of this minus. But this minus actually has effect on everything. Then plus, open under bracket. What's my y? My y is 3. Then my y2, sorry, my y2 is 0. Y2 is 0, not 3. Then minus. What's my y1? My y1 is 3. Then square it. So the distance between M and N is equals to the square root of, this will give us what? So 6 minus times minus will give you plus, then 2, you square it again, then plus, open under bracket. 0 minus 3 will give you minus 3 square. So which is equal to square root of, now 6 plus 2 will give you 8, then you square it, then plus minus 3 square. So now square root of 8, 64, then plus, what's the square root of minus 3? It's 9. You can use your calculator to find it. So now you discover that the square root of, so 64 plus 9 will give you 73. So that is